Welcome to Bite-Size Data Science. In video 63, we talked about some types of modeling, including clustering, classification, and regression. We saw that with regression and classification, we need pre-scored or labeled data. There are other types of algorithms, such as collaborative filtering, used to create recommendation engines, and, of course, neural networks for deep learning. You can watch video 8 and W3 on alternative least square that relates to recommendation engines, and video 23 to 26 on neural networks. At this point of the data science lifecycle, we want to create a model on our data. Since we previously identified the type of problem we are trying to solve, we should know the type of algorithm we need to use. There are likely multiple candidate algorithms that can fit the bill, and we need to try a few of them. That's where tooling like the ones mentioned in video 63 can save a lot of time and effort. Data preparation includes tasks such as converting strings to numbers, normalization, dimensional reduction, categorical choice reduction, data balancing like in the case of churn, feature engineering like extracting the day of the week from a date. When creating a model, we need to keep in mind what is the data we need to score. Will that data need to be pre-processed before it can be scored? Most likely, that will need to be done. We could provide a library that applications could use to prepare the data before being scored. Another approach is to use a pipeline. Here is some code showing the use of a simple pipeline. It first creates a list of columns that we want to transform. In the next statement, we create a pipeline that has two steps. The first step uses a simple imputer class to fill in the missing values. Then it encodes the values using the one-hot encoder. It makes sense when looking at the columns that are to be processed. All of these columns have few possible values, which fits well with one-hot encoding. The next step creates a column transformer that applies the pipeline we just created on the columns from the list categorical features. Finally, we create a pipeline that uses our column transformer before calling a decision tree classifier. This last pipeline becomes the object we use to train our model. Here's how it is done. We split our data into train and test. The X-train and X-test represents datasets we use to train and test, and the Y-train and Y-test are the labels or scoring results for their respective X datasets. In the next step, we call the fit method on the pipeline we created earlier to create our model. At this point, we have our model and we can use it on test data. Since the model is based on a pipeline, all the proper transformations are applied before it calls the decision tree model. If we think back of the data preparation we did in videos 60 and 61 using lookup tables, we would require custom transformations. We could create pipelines that use transformations that access a relational database table. A lot of thought needs to go into it as it relates to performance. We also have to think about the cases where a value is seen for the first time. Do we add it to the appropriate table, or do we use a default value that represents unknown? Anything is possible, it's only code. The business problem we are addressing dictates the type of algorithm that will be used. The final model we create has to take into account the format of the data that will be scored. We could provide a transformation library, but it is just another independent piece of code we need to maintain and keep in sync with the rest of the solution. Using a pipeline is likely the best approach to make models available. See you next time on Bite-Size Data Science, and don't forget to subscribe.